Hello, now I'm going to solve the problem 11-12 from the Intermediate Accounting Volume 1 IFRS edition. My name is Nilu Madia Amanda Wulandari Sudirga. My student ID is 377159. So here I have already done the problem, but we are going to try to do it together. So let's see the question first. The first instruction is to prepare a schedule showing estimated depletion and depreciation costs for each year of the expected life of the mine. And then the second one is to compute the depreciation for the first year and also the depletion assuming that the production of 5,000 tons occur with no additional changes. So, okay, let's begin with the first paragraphs of the problem. So, Kamsa Mining Company has purchased a tract of mineral land for 900,000. It estimated that this tract will yield 120 tons of ore with sufficient mineral content to make mining and processing profitable. It is further estimated that 6,000 tons of ore will be mined the first and last year, and then 12,000 tons every year in between. So the company assumed 11 years of useful life and the residual values of 30,000. Okay, so the first paragraph tells about the mineral resource. So we have a 900,000 for the purchase of the mineral land, and then we have 30,000 for the residual values. So we get the depletion space of 900 minus 30,000, which is 870,000. So we have 870,000 of depletion base, and then it is estimated to yield 120,000 tons. Here we use the activity method because the mining depends on the tons of ores available. So if the tons is used up, then it is no longer useful for the company. So we use the activity based instead of the other methods, because it is the most suitable one. And then we know that the first and the last year will be mined for 6,000 tons, and the year in between will be 12,000 tons. So here, okay. So the first is to deplete the mineral resource. So we have the depletion base of 870 because 900 minus 30,000, because we use the activity method, so we use the residual values. And then from the question we know that the estimated yield is 120 tons. So divide the depletion base and the estimated yield, we got 7.25, which is the cost per ton, the depletion per ton. So to find the first and the 11th year depletion, we just times 7.25 times 6,000, because we know from the problems that the first and the last year, which is the first and the 11th year, we estimated that we mine for 6,000 tons. So we got 43,000, and then for the year in between we will mine 12,000 tons. So 7.25 times 78,000 times 12,000 equals to 78,000. So that's the depletion. Oops, sorry. And then the second one is the company builds necessary structures and sheds on the site at a cost of 36,000. It's estimated that these structures can serve 15 years, but because they must be dismantled if they are to be moved, they have no residual value. And the company does not intend to use the building elsewhere. So, is this a depletion? Should we depreciate this building or depreciate this building? This building is a tangible asset that cannot be moved, or the company does not intend to move it. So this building is depreciated because it's a tangible asset that cannot be moved. And then it can serve 15 years, but because the company will only use it for 11 years of useful life, because the mining can only be useful for 11 years, so instead of 15 years useful life, we are going to use 11 years for this building instead. And then the second one is mining machinery installed at the mine was purchased second-hand at a cost of 60,000. This machinery cost the former owner 150,000 and was 50% depreciated. This information is not important for this problem. If we're going to make a equipment account, then yeah, like the trade values and stuff. But now this is not important. And then Kamsas Mining estimates that about half of this machinery will still be useful when the present mineral resources have been exhausted, but that dismantling and removal costs will just about offset its value at that time. And the company does not intend to use the machinery elsewhere. This means that half of this machinery is estimated to be to have useful life more than 11 years, just like the building. But because the mineral resource will only be available for the 11 years, it is estimated to be useful for 11 years. So we use 11 years useful life instead. We just use the closest one. And then because the company does not have the intention to move the machinery elsewhere, and it is a tangible asset, so we depreciate it too instead of depletion. And then the remaining machinery, the other half, will last until about one-half the present estimated mineral ore has been removed and will then be worthless. So the remaining machinery, the other half, will only be useful for one-half of the present estimated mineral ore, which is 11 years. So the other half machinery will only last for about 5 years and a half, and then will be worthless. So the cost is to be allocated equally between these two classes of machinery. So 60,000 will be allocated 30,000 each. Okay, so we are going to depreciate. From the second paragraph, we depreciate the building, the machinery 1 and the machinery 2. I'll just call that. So the building, we know that the cost is 36,000 without residual values. And then to know the cost of the per ton mine, we just divide 36,000 divided by 120,000, because that's the estimated ton yield. Yeah, and then we have 0.30 for the building. To find the depreciation, the first year is the same as the depletion base. We just equals the per ton mine times 6,000, because we estimate that the first year is 6,000 tons, so 1,800, and the second year 0.3 times 12,000. We got 300 at 3,600, and so on until the 10th year, and then the 11th year we use 6,000 because we mine 6,000 tons again. We got 1,800. If we sum them up from the first to the 11 years, we are going to have the same values as the cost, so we get 36,000. So yeah, and then the first machinery, the cost is equally distributed, so 30,000 each, 30,000 and per ton mine. The first machinery is estimated to have longer useful life than 11 years, but because we are going to use because the mineral resource will only be useful for 11 years, so we use that instead, the closest one. So we estimated that the first machinery had 11 years of useful life. And then while the second one have a useful life of the 1/2 of the estimated, which is half of the 11 years, or the depreciation will be 2 times faster than the first machinery because it's going to be 1/2. Understand? So yeah, to get the per ton mine for the first machinery, we just divided 30,000 by 120,000, like the building one, and we got 0.25. To get the first year depreciation values, we just 0.25 times 6,000, we got 1,500, and then for the second year times 12,000, we got 3,000, and so on until the 10th year, and then again times 6,000 for the last year. We got 1,500. If we sum them up again, just like before, we will have the same values as the cost. Okay, we got 30,000. So yeah. And then the second machinery will also cost 30,000, but the per ton mine cost will be 2 times larger than the first machinery because it depreciates 2 times faster. Its useful life will only be half of the first machinery. So yeah, we times the 0.5 times 6,000, we got 300, and then we continue until the fifth year. If we sum the 5th year, the first till the 5th years, we will have 27,000 of accumulated depreciation, but the cost is 30,000. So how much cost do we need for the 6th year? 3,000, of course. It's like 30,000 minus 27, and it's also because it lasts for 5 years and a half, for 1/2 of the 11 years. So yeah, so we got 3,000 for the 6th year, and it's actually zero depreciation for the following year. If we sum them up, we'll get 30,000 as well. Okay, so now the second question is to depreciate and deplete the same mineral resource with the same estimation, same structures and equipment. If we assume that the actual production is 5,000 tons, so instead of 6,000, we multiply 7.25 with 5,000. So we got, let's try to multiply times 5,000. we got 36,250. So for the depletion of the mineral resource, we depleted for 36,250, and then for the depreciation of the building, we got photon mines 0.30 times 5,000, and we have 1,500. For the machinery, for the first machinery, 0.25 times 500, we got 1,250, and then the second machinery, we got 2 times the first machinery amount, which is 2,500, and we sum them up and we get 5,250. So that's it. We have already answered the A's and B question of problem 11-12. I hope it helps. Thank you.